Today we're learning about refraction, which is the bending of light when it passes from one material to another. By the end of this lesson, you'll be able to state examples of refraction, describe what happens when light is refracted, and explain why refraction happens. In the ray model, we often say light travels in straight lines. But is that always true? Let's test it. If you put a pencil or straw into a beaker of water, half full, and look from the side or the top, the pencil seems to bend or break at the water's surface. That's our first clue about refraction. When an object is in water, like in a swimming pool, its position seems to change. That's because the light rays reflected from the object bend when they pass from one medium to another, such as water into air. Light travels at different speeds in different transparent materials. It's faster in air, slower in water or glass. This change of speed causes the light to change direction. Imagine a toy bulldozer moving from a smooth workbench onto sandpaper. On the smooth surface, it moves quickly, but on sandpaper, it slows down. If it drives straight on, both tracks meet the sandpaper at the same time, so it slows but keeps the same direction. That's like light hitting a boundary head-on. Now imagine the bulldozer meeting the sandpaper at an angle. One track hits the rough surface first and slows down, while the other keeps moving faster. This makes the bulldozer turn. Light behaves the same way. When one side slows first, the ray bends into a new direction. We can represent this bending with a ray diagram. The angle of incidence is measured between the incident ray and the normal line. The angle of refraction is measured between the refracted ray and the normal. This helps us compare how much the ray bends. To investigate refraction, we'll use a ray box, a glass block, a protractor, ruler, paper, and pencil. We'll shine a ray of light into the block and measure how it bends as it enters and exits. Place the block on paper and trace around it. Draw a normal line at the entry point. Shine a ray at 10 degrees incidence. Mark the incident ray, the refracted ray inside the block, and the emergent ray as it leaves. Then measure the angles with a protractor. Repeat for 20, 30, and 40 degrees. Compare how the angles change. Be careful. The ray box bulb can get hot, so handle it carefully and switch it off when not in use. Power packs carry current, so make sure they're set up correctly at the right voltage. Record your measurements in the table. Write down the angle of incidence and the angle of refraction for both entry and exit. Start with 10 degrees, then add the others. When light goes from air into glass, the angle of refraction is smaller than the angle of incidence. The ray bends towards the normal. When light goes from glass into air, the angle of refraction is larger than the angle of incidence. The ray bends away from the normal. This happens because light slows down in denser materials like glass and speeds up in less dense materials like air. You may also notice that the entry angle equals the exit refraction, and the inside refraction equals the exit incidence. Refraction is the bending of light as it passes from one material to another, because light changes speed. Examples include a straw in water, a swimming pool that looks shallower, and a magnifying glass. Characteristics: light bends toward the normal in denser materials and away in less dense ones. Non-examples include reflection, shadows, and light traveling straight through air. Another example is using a magnifying glass to read small text. Today we've learned to state examples of refraction, describe what happens when light is refracted, and explain why refraction happens.